Hello, Adrit. I'm audible. Okay, Adrit. So we are done with the problem solving. Okay, we are done with the complete chapter. Okay. Any topic which you think we are missing and we have not done yet, or any kind of doubt you have, anything, whatever you would like to learn, you can just let me know. So yeah, you can just type like if any doubt is there or something. Because we are done with the main conceptual topics with respect to this chapter, what is important for us. So So yeah, you can just come up with something like any topic which we may have missed, any topic in which you have doubt, or something which we have to do it again, or anything. Okay. After this, we are just left with the problem solving practice part. Okay. Adit, any doubt or something? Um, okay, I'm assuming you don't have any doubts, so I will end this by now. Basically, this PPT. I'll be sharing you one notes. Okay. Basically, problem notes, not just normal. We'll be solving problems hereafter. Is that clear? All right, Adit. So this is a page where all you can see a lot of problems are there. So we'll be solving all these problems from this exercise part. Okay, one by one. We'll try to go further. So Adit, I have shown you the problems. You can just let me know. Like start from the first. These are basic subjective questions, so I don't want to go much more deeper on this. Just let me know if you which problem you are not able to get. Okay, in this subjective part first. After that, this from second part we'll go further. First, just like for what is essential condition for vector addition and all, you just have to think of it which you are not able to get it. Else, we will do it by ourselves. I'm not sure that why I'm not responsive. Okay, so I'll just give go one by one. So first of the problem says that what is the essential condition for addition of two vectors? So a very simple thing. The nature should be same. What does this mean? Nature, when I say that a vector, if it is representing the meter or distance, so you can't do something like that. You are adding two vectors which are of not same. Okay. You can't add a speed vector or velocity vector to a displacement vector. Understood? Okay. You can't add a force vector to a velocity vector. Is that clear? Because the unit are same. It's not about the vector also. You can't do in a scalar also. If I give you 10 Newton and I say add it with the 5 meter, it is not possible because they are very different quantities, right? You can't add 100 kilometer into 1 meter, like 100 kilometer to 1 meter. You have to make a conversion of it, but we don't have any conversion from force to meter, right? Because they are different physical quantities itself. Okay, when you have, so whenever you add something or subtract something, their physical essence should be the same. Okay, is addition of two scalar quantities meaningful? No, actually, every time it is not a meaningful thing. Okay, So that is like basically any two quantities, scalar quantity cannot be again when you add it is not a meaningful because adding a mass of 1000 kg to another mass of 100 kg gives me 1100 kg. That makes sense. But if I say add the 1000 kg with the maybe 20-meter distance, doesn't make sense. What you are going to get from there? Nothing. It's like you can't get some mixture of kilometer and meter. Okay, that you will be getting from the either multiplication or either division, not from the addition or subtraction. Make sense? Okay, they must represent. Okay, understood. Yeah, for subjective, like it will take time, so I'm going further by myself. False. Exactly. Exactly. Okay, can two vectors of the same magnitude add to give? Okay, this is a component of a vector can be scalar. The component of a vector can be scalar. Is straight true or false? No, again, it's a vector, right? If they have asked about the magnitude and all, then I could have looked at something, but no. Can two vectors of the same magnitude add to give zero resultant vector? The answer is yes, right? The answer for that is yes. Okay, what is the condition, Adire? For the D part, what should be the ideal condition? What is the ideal condition for D? Adrit, if you could have just turned on your mic, it would have been better or easier for us to go with the solution because writing, if you will be typing, it will take time. It might be the thing which you can explain me in 2 or 3 words. It will take a whole of sentence you to type and let me know. Okay, so that is what our concern is all about. The solving problem solving part. Okay, so yeah, basically, when you are going to get addition of two vectors here, the first of all the vectors, the magnitude is supposed to be same and the direction is supposed to be opposite. Okay? If this is a condition, when magnitude is same and direction opposite, then you are going to get the zero vector. Okay? Can two vectors of a different magnitude add to give zero resultant vector? Mm, okay, first of all, two vectors having different magnitude are not going to add you to give zero resultant vector. Okay, three vectors can give, but not two. So that is the thing. Three vectors can give, not two. Okay. It is asking about the after that. Can three vectors give zero? Yeah, they can. But for the three vectors, the ideal condition is they are supposed to be a coplanar vector. Coplanar mean to say we have already studied one thing about the coplanar. If three vectors are coplanar, then they can give it to zero. Okay, then they are supposed to giving the zero resultant. Else they won't get. Can a rectangular component of a vector have magnitude greater than the vector itself? No. The magnitude can never have a component greater than the vector itself again. Okay, so that is one thing. Can a vector be a zero if one of its component is not zero? Um, no, actually not. A vector can be zero, okay, only if and if all the components are going to be zero. Find that thing. Can scalar product of two vectors be a negative quantity? Scalar product of two vectors be a negative quantity? For this, the answer comes out to be what do you think? Can it be negative in any ways? I can say yes. Because if you could remember, the scalar product is written by AB of cos theta and. There is a high chance of having the theta to be negative. Let's say this is 120. What is the 120 degree? Minus 1 by 2. Got it? So you have got it negative. So you can actually get it. Okay. Okay. So Adrit, we are at the G part, B part. We are done with the H part. Any doubt till here? Any doubt till here, Adrit? No. Okay. So let's move further. Okay. I part is there. State condition. Okay. Wait, I'm not able to type. Okay. State the condition for which vectors are parallel to each other regarding the value of dot or cross. Okay, we have to go it that way, and we have to tell whether the vectors are parallel to each other or not. First is they are parallel to each other. So you know if they are parallel to each other, their cross product is going to be zero, right? Because the angle is zero. Yeah. Cross product is zero, and dot product has some value. Okay, for this one, cross is zero. Perpendicular to each other, dot is zero. Basically, the dot product is zero. Okay, the rest product, other part are, have some value. Okay, is position of a vector and direction sufficient for calling a quantity a vector quantity? Okay, for anything to be called as a vector quantity, it is supposed to be follow. It is supposed to follow vector rules. Okay, whatever the vector rules are there, and what are those rules? It should have a magnitude. It should have a direction. Okay, these are some basic specific rules. Okay, but not these just thing. Okay, it should not only happen to this part, it should be following the vector multiplication, what we used to do in case of a dot b. Okay, a cross b, these are all the things which makes, like, combining all these things just make a vector quantity, not just by saying that okay, you have a magnitude and direction, you are a vector quantity. No, this is not a possible thing. I will give you an example of current. Okay, because what happens when you will be in the next upcoming grade, in the 12th, you will be studying that current goes in a direction, and that matters a lot. Current has some value, so I can say that current has some value and has a direction. So can I write it as this? No, because it is written for the vector. Current is not a vector quantity, but have two properties which is also as of vector. It has a magnitude, it has direction, but still it is not a vector quantity because it doesn't follow the multiplication rule of vectors. Understood? To be a vector, it should be always follow all the particular rules defined by a vectors, all the rules which a vector follows. And the main part is magnitude, direction, and multiplication, basically product of vectors, following the cross product and dot product. Okay, which this I fails to do. Understood? I've I've this current follows a scalar vector, a scalar product. Okay, it follows a scalar rule. It means if you are given four in this current goes in four in this direction, current goes five in this direction. What you can simply say that okay, the total might be after this, it will coming as four plus five as nine. It is not a vector quantity, right? In vector, what could happen? It might be going on the basis of some angle theta. Okay, what is the angle theta? On the basis of 4 cos theta, something will be going in these directions, but it doesn't happen here. So yeah, for this you can say no. Okay, cross is zero, dot is zero. Other, did you understand the J part? Bit of theoretical topic is that. Yes, fine. Okay, let's move to the next. Okay, so yeah, is it necessary that sum of two unit vector is also a unit vector? No, it's not necessary. You can simply say that I plus j. This is a unit vector. This is a unit vector. What is it is going to give? You can't say it is not giving anything. Okay, it is not giving you anything. So yeah, it is giving you actually a vector. So what is that vector? This vector is something like this: one in this direction, one in this direction. You are getting this point. This is your final vector. If you color the magnitude, it will be root two. Root two in this particular direction. Okay, I plus j is the direction. So yeah, you can see it is not a vector. It is its magnet. It is not a unit vector. It has some value, right? Another way, this is I plus I. Two unit vectors add, you will get two I. Is it a unit vector? No, it is not a unit vector. So again, it is not necessary to have a unit vector when you add total thing. Okay. Okay. What is the difference? What will be the difference in the product of a real number with a vector? Okay. What is the difference, and what will be the difference in the product of a real number with a vector and a scalar with a vector? explain the difference between the data which is given to me in the next part. Okay. So the first thing is it's L part, right? When you multiply product, they're asking about the product. When you multiply a real number with a vector, let's say initially vector was 5i. When you multiply any real number, let's say 2. When you multiply 2 into 10, what happens is anything doesn't change, just magnitude changes. Okay, just magnitude changes, nature remains same. Clear? For this part, scalar with a vector. Okay, scalar with a vector, again the same thing. When I say scalar, mean to say I'm just multiplying some magnitude part, right, with a vector. Again it just changes the magnitude part, nothing else. Okay, nothing changes over here. So yeah, we have done these two things. Let's go more of this part, the data part. We have to explain the difference between this thing. Okay, what is that? In the first case, we are multiplying 5. Basically we are multiplying 4 with these things. Okay, with these things. So what does this mean? It becomes, look, the first part, we are multiplying 4 into 5, so it becomes 20 kilometer per hour. Okay, this becomes 20 kilometer per hour, and it is in the east. Direction is given as east. Okay, this is what it is given to you. Okay, so final result, you can say that you have got 20 kilometer per hour speed in the east direction. It might be like this, 20 kilometer per hour in the east direction. Okay, the next is you are multiplying 4h into this, so it goes as 5 into 4, 20 kilometer, h inverse and h, it will become nothing. So it is giving you 5 kilometer, okay, in the east direction. Earlier you had speed, you can simply say that kilometer per hour, it's a speed unit. In the first case you are given speed, basically it's not speed, this is a velocity given to you, because it has a direction also. This is also given a speed, displacement actually. Okay, because 50 kilometers is the magnitude of displacement and east is the direction. 20 kilometers, okay, this is 20 actually, not 50. 20 kilometers is the velocity, magnitude of his velocity, east is the direction. Other, this L part is clear to you or not? Let me know first. Okay, so we can move to the next. I will erase all this that it looks clear. This is one. Let me have a reload. Okay, so we are done for these things. Okay. Let's move to the main of the problem solving part. How many problems we have? You can see too many problems we have. I will try to skip most of them basically. Okay. And I will share you the sheet. You can try all the problems. If you have any doubt, you can just mark those. Okay, we will do those in the next class. Okay, because you can see there's a lot of problem and we can't solve each of them in the class itself. I will try, like I will suggest you to solve all the harder problems which you can do from this particular sheet. Okay, so let's come up to this. Two equal forces have a resultant equals to 1.5 times either force. Okay, it's a good thing. Basically, you are given A force, B force, and assume that magnitude is, they have okay, two equal forces, right? Magnitude is equals to something A. Okay, this is equal. Resultant has, resultant equals to 1.5. Mean to say, what is 1.5? It is like 1 plus 1 by 2. So it is basically the resultant is nothing but 3 by 2. 3 by 2 times. This is the resultant. And these are two vectors. We have to calculate the angle between them. You can simply say that resultant is given as 3 by 2 times of A. How we calculate resultant? Under root A square plus B square. So A square plus B square is again A square plus 2AB B into A square, angle of cos theta. So you come up with this thing, square both sides. It comes out as 9 by 4. A is equals to, it's like 2A square. This is also A square plus 2A square cos theta. So you can say that A square get cancelled out. Whatever you are left with, you can subtract it and get the answer. You, when you do this, this will result you around 1 by 4 is equals to, what is that part? It is 2 times of, I think, cos theta. So yeah, it is, I think, if I have not made a mistake at this particular point, so it should be the same. Yeah, actually it's correct. So yeah, I have not made any mistake. So this comes out as cos theta is equals to 1/8. So theta, you can simply say that cos inverse 1/8 comes out as an answer. If you just go at the, okay, we don't have any options for this, so this is the correct answer. Okay. Any doubt in this one? Second part. So count them others. Others, put it over there first. No, no doubt. Okay. Okay, so let's move to the next problem. This is the next problem. At what angle two forces, this and this, act so that the resultant is A and B? Okay, so two conditions are given. In the first case, resultant is this. In the second case, this is that. So I think you can try this one. Okay, I will do just one part out of this. Let's say I'm doing for this one. You can do for this one. Okay, the both are same. This angle will come out as different. Okay, so what are the ways how we can go up to this? You can simply say that r square is nothing but the same formula which we used to apply earlier. A square plus b square plus 2ab of cos theta. So what is r? That is 3 under root in 3p square. So when you do square, it will become just this thing. Okay, a square is given, and what is the a basically? A square is okay, p plus q, right? So that is p plus q. So when you do the square of a square, it will become p square plus q square plus 2pq. This is this thing. B is p minus q. So this will become p square plus q square minus 2pq. Yeah, I think this. And a into b plus 2 times of a into b. So it is like p square minus q square times of cos theta. This is what you are going to get. So you can simply remodify the thing. P square plus p square will result to 2 times of p square plus 2 times of q square get cancelled out plus 2 times of p square minus q square cos of theta. Okay, this p square will go that way, so it becomes just p square. The this 2 of cos theta will go that way, it will become minus q square. That results out to p square minus q square cos of theta. Cancel, cancel. What you have got in the final answer, that is cos theta is equals to 1/2. Theta is equals to 60 degree. Clear? Just go and solve it, solve it, solve it. At least at the end of the day, if your method is correct, some point the some cancellation will happen, and you will get the correct answer. Clear? Okay. So yeah. So yeah, this is the second part. You can try this by yourself. Two forces A and B simultaneously on the vector. What is the value of the maximum resultant, minimum resultant? What will the resultant if forces are at the right angle to each other? Again, same thing. Let's go with the formula again. Look, all of them are very simple, basic formula based. A square plus b square plus 2ab of cos theta. Okay. What are the things given to us? 7 or 3. So this is 7 square 49, 3 square 9 plus 2 into 4 into 7, I think, right? No, 7 3. 7 square 3 square 7 3 21. This comes out as 42. And cos theta. Now. This is the resultant whole of. You can see this is a constant part. This is a variable. Cos theta. What is the maximum and minimum value? Minus 1 this. So when the question says get me the maximum resultant, I will put the maximum value of cos theta. When the question says get me the minimum resultant, I will put the minimum value of the cos theta. When question says it is at the right angle, mean to say 0, cos theta is 0. So you can simply say that R max is nothing but 49 plus 9 minus 42. So 42, if you subtract it out, you are going to get something around 7 plus 9, it is 16 under root. R max minimum will come out as, no, wait, this is the minimum. Okay, For maximum, you just have to add both of them. I just made a small mistake. This comes out as 91, I think, and 100. This whole thing comes out as 100. So this is 100 under root. Minimum comes out as 16, and this R at the right angle 90 degree. This comes out as 49. This 58. Okay? So this is what it is all about. You can try solving this by yourself. Understood? Yeah, exactly. 10 and 4, and you have got that. Okay, that's correct answer. All right, Adit. So I think okay. Find the resultant force of the following vectors acting upon us simultaneously. Resultant force of following forces which are acting simultaneously. Okay, all four forces are given. All of them are acting on a particle at a same direction. Okay, at the same time basically. So it's a very simple. This is a point. 30 Newton towards the east, 30 this way, 20 Newton to the north, 20 this way, 40 in the south this way, 50 in the west, 50. So you can simply do one thing. You can say this direction, one is I direction, one is J direction. What is the net force in horizontal? So you can say the net is 30I minus 50I. This is my net direction horizontal. How much? F in x direction. That is basically minus 20I. This is the net thing. In Fy, if you calculate minus 10 times of J. So what is the net force you are having? You have to get the resultant, right? So what is the resultant? Basically, you can simply say that A is nothing but 50I in the uh, is it no minus 20 basically in the negative. B is nothing but minus 10 in J direction. What is the magnitude? Magnitude comes out as 20 square as 400 plus this 10 square as 100. You magnitude 500. You will get the answer. Clear? Clear, Adil? Okay, this is the way basically. It's a simple thing. You just have to add all of these. Okay, wait. I think this north and south should result you minus 20. Yeah, y should also result you minus 20. This should result. Oh, this also results to minus 20. This also results to minus 20. Rest will be same. Okay, method is same. You can see. Okay, Adit. So wait. I want to go each of them. Just let me know out of these which problem I should solve. Six, seven, eight, nine. Out of these four, which problem I should solve? Which you don't think you won't be able to do? If no, then I will move to the next page. Okay? Let me know which problem I can solve and the rest you will solve by yourself. Eighth problem. Okay. Let's do the eighth one. Find a unit vector along and opposite to the this vector. Okay, that's fine. Look, it is very simple. I don't know why you chose this problem. You should have chosen some other problem. Let's remove this part first. Okay, I'll just refresh it. Okay, so look, what the question says, you have to get out the resultant vector. Okay, but before that, let's see which vector they are asking. The unit vector and opposite to this vector. So let's calculate the opposite first of this. What is the opposite? Mean to say I can just put the negative. Can you put negative out of it? This is the vector. You have to get the unit vector out of this vector. What you can simply do, you know the vector. I can say this is a vector required. How we generally calculate unit vector? A vector is nothing but a magnitude times of a unit vector. So this is a unit vector. A vector divided by the magnitude. So minus 3i. Okay, minus 4 of j. This will become plus because minus plus. Minus 12 times of k. And whole is divided by 3 square, 4 square, 12 square 144. 9 plus 16 plus this is 144, I think. If you add all of them, I think what you're going to get here is what you're going to get. This results to 25. Okay, when you add all of them, you are going to get 169, I think. Okay, 169, that is 13's under root. So you can simply say that this is the unit vector which you are going to get. Clear? Okay, it's better if you just keep this negative outside. So this is the thing. Keep the whole negative outside. It looks clean actually. Negative. In the initial it was negative initial cost. So this is the vector. Other eighth one is clean. Clear, yeah, 169. That's correct actually. Okay. So from this ninth, you can see. Let's move further. And okay, do you have doubt in the ninth problem, or we should move further? Look at the ninth problem. Two vectors are given: vector A, B, and C. What to find? Okay, this is what you have to find out. It's an easy. You just have to multiple do some scalar multiplications, and just add both of all of them. Okay, I think you can do this by yourself. I'll move further. Okay, look at the 10 to 15. Out of 10 to 15, look at the problem. No, sir. No forward. Like you can't do that ninth one. Okay, let me know which problem I should solve next. Sir, you told any doubt in. Yeah, yeah, okay, fine, 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 fine. So you don't have any doubt, right? No, I'm saying, what is the next problem you have? You want me to solve? Just let me know the problem I should solve. Okay, I'm changing the screen. Look at the 16th problem. Yeah, okay. This is the full page. Look all the problems. Let me know which problem I should solve the next. Read this whole page and let me know which. Okay. 20, Sorry, Adit, my mic was turned off and I was explaining a lot of things. Okay, I think I have to explain it again. Okay, Adit, what I was saying is, assume you are given a single vector. Okay, this is a point. From here, it is forming a some angle on this vector. Okay. You know another vector is there. Yeah. This is making how much angle? 2 pi by theta. Okay, 2 pi by n basically. I will call this as theta. This will- So what is this angle I have to calculate? I know, Adrit, that if this angle is theta, I can simply say the whole of this angle is 180 minus theta. I can simply say this, right? Okay. Also, I know, Adrit, this particular angle and this particular angle is also same. Can I say this? If you go to another vector, because I know this length of this vector is same, it means this whole angle is divided into two. Okay, so this thing come like 180 minus theta. The whole was 180 minus this is theta, right? So this whole thing is 180 minus theta. Okay. So what will be this part? This part is nothing but the whole thing by two. Clear? This is also the whole thing by two. So you can simply say two times of this thing. Summation of this. If you do this, you are going to get this thing. And the total is 180. If you subtract the whole thing, what you are going to get is theta. And this is the theta. Is this clear part for how to calculate this theta, this and this angle? This alpha basically comes out as theta itself, the outer angle. Let me know if you're clear with this thing. Other fast, let me know if you're done with the calculation of this theta part. If you don't have any doubt in this part or have any, let me know. Adrit, are you doing it? Let me know first. Adrit, are you theta? Okay, no. It is not 360. You are telling the total theta. Okay, total theta 360. Okay. So when the total is theta 360, what does this mean? That look, when I say the angle is assume, let's say I'm saying theta, it means it started from here, it ended here. When I say the angle is 360 degree, what does this mean? Someone started from here, someone ended up here. What does this mean? One angle, two vector, another vector, another vector, another vector, another vector. It started from here, went up this way, 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 went up this way. You can see the total angle 360. Okay. It means it is forming a circle, and when something forms a cycle, when all the vectors are forming a cycle out of it, you can simply say that net resultant vector comes out as zero. Is that clear, Adrit? All right. So look, the same. Okay. In the 24, two vector p and q are given at a point such that if p is reversed, point is given basically. If p is reversed, the direction resultant turned through 90 degrees. Then prove that magnitudes are equal. As the question is saying, assume this is p, this is q. The resultant is coming out like this. Okay. If you just turn this, mean to say if you make it like this. Okay. So let's say by 90 degree, either this vector will move this way. So we have to just prove that this P and Q were equal in the magnitude. Clear? So look, you can simply say that my resultant is coming out as P plus Q. Right? I can simply say this. Okay. And what is the next condition? Assume R is another vector S, assume I have some another vector S which is perpendicular to R. S is another vector which is perpendicular to R, and this is equals to minus P plus Q. Okay, understood? Why I'm saying, because the question says when you reverse the P, the this resultant is going to get perpendicular. Okay, so I can simply say that I have taken another vector which is perpendicular to S. Because why I have not taken? Because perpendicular can be in multiple directions. This can be perpendicular, this can be perpendicular, this can be perpendicular, this can be perpendicular. So we are not sure of it. Okay, if let's say this was P, this was in earlier Q, this is thing. So if P moves this way, although the R should indirectly R should have moved to this direction because this is the ideal P. Okay, so we actually don't know which direction it has moved, either this way, this perpendicular. So I have just taken a random S. Clear? You know that this R resultant and S resultant are perpendicular to each other. Then I can simply say that the dot product of these is supposed to be zero. I can simply say that I have got this idea that if they are perpendicular to each other, their dot is supposed to be zero. You can simply go and do the dot product. P plus Q dot minus P plus Q. The dot is zero. What does this mean? Okay, the dot is zero. So instead, you can simply multiply each of them. When you do this, you are going to get minus P square plus Q square is equals to zero. This will result to P square is equals to Q square magnitude. So P comes out as Q. Others, let me know if you're clear with that as explanation for the 24th answer. Adrit, is it clear the 24th answer? Okay. So look, Adit, by this I'm ending the session. Okay, I will share the PPT with you. Try all possible questions. In the next class, I will only discuss the problems which you are not able to make. Okay, I will share this whole PPT of the 6 pages. This question problem sheet of the 6 pages. You can solve it and let me know which problem you are not able to solve. Okay? So by this, I'm ending the session. Okay. Goodbye.